lesson, we're going to talk about performing function operations. So the way you do these isn't anything new to you. The only thing that's new is the notation that you're using. So if you take a look at these notations, this just means f plus g of x. That means you're going to take whatever the f function is, and you're going to add that to whatever the g function is. This does not mean you add f and g and then you multiply it times x. This is just a notation. So when you get done, don't distribute an x through all of your stuff. All right? You're just literally taking f and adding that to g, or the f function minus the g function, or f times g, or f divided by g. So we've done all of those things. We've just never used this notation. All right? So now that we know that, oops, didn't mean to go in that far. Let's try one out. So we're going to do one adding, one subtracting, well, two subtracting, couple multiply, couple divide. All right, so there's three things you have to do on this problem. First, it says find f plus g of x. Then state the domain, and then evaluate the sum when x is 4. So first, we're going to find f plus g of x. That literally just means I'm going to take whatever f is, which in this case is 3 square roots of x, and I'm going to add that to whatever g is, which in this case is negative 10 square roots of x. And if I can simplify that, then I need to. I notice that I do have like roots here, so I'm just going to combine the 3 and the negative 10 to make negative 7 square roots of x. So when I add them together, I get negative 7 square roots of x. So there is part 1. Second part is the domain. So here's the deal. Your domain starts off as all real numbers. And then when you start having variables like underneath an even root or in the denominator somewhere where there are restrictions, then you have to start restricting your domain. So for instance, right here I see that I have x underneath a root. So what you're going to do is you're going to take whatever is under your root and you're going to set that equal to 0. In this case, all I have underneath is x. Now, the things I want to avoid under an even root would be a negative number. I don't want a negative under there because if I square root or fourth root or sixth root a negative, I'm going to get an I, right? I don't want an imaginary number. I just want all real answers. So all of my numbers have to be something in reference to 0. So all of the numbers under this root would need to be greater than or equal to 0 because I don't want any numbers that are negatives. So my domain would be x is greater than or equal to 0. Let's say, for instance, though, that I had x minus 2 underneath here. All right? I would set that equal to 0. I would solve for x. So I know that all of the numbers that can be plugged in for x have to be something in reference to 2, either bigger or smaller. But I know that when I plug in 2, 2 minus 2 gives me 0, right? That's like my starting point. So do I want those numbers to be bigger than 2 or smaller? Well, if I plug in 3, 3 minus 2 would give me 1, right? So numbers that are bigger than 2 give me positives, so I would say greater than or equal to 2. So it all just depends on what you have under there, all right? In our case, we just had an x. Now, I'm going to be plugging in 4 into what I found right here. So I have f plus g of 4, just stating that I'm plugging in 4. So I have negative 7 times the square root of 4. So f plus g of 4 is equal to negative 14. So now let's talk about subtraction. Now, we've subtracted polynomials, right, before. You have to remember that when you subtract, it doesn't matter really about the front one because there's nothing that's going to be in front of that to make a difference, all right? But when I subtract, that function that's behind the subtraction sign, you're going to have to distribute that negative throughout that entire thing. So I'm going to actually put that in here with parentheses so that we have that in our notes. But if you were doing it in your homework, you wouldn't actually have to show that. You could just do it. So if I'm subtracting, I'm taking F and I'm going to subtract G. So I have 3x to the third minus 2x squared plus 5. And I'm going to subtract. Now this is where it's important because I'm subtracting this whole thing, right? So it's important to know that we're subtracting the entire thing. So I'm going to put it in parentheses. And this is something that we've done in the past. Just a different notation. So when we subtract, we have to subtract every single term that comes behind that. So the front, it doesn't matter because that's in front of the minus sign. But now I have to distribute this negative. So negative 1 times x cubed is negative x cubed. Negative 1 times negative 3x squared is positive 3x squared. Negative 1 times 4x is negative 4x. And then negative 1 times negative 2 is positive 2. Now I'm just going to simplify this by putting my like terms together and making sure I order this properly. So I'm going to start with the cubes. I have a 3x cubed and a negative 1x cubed, which gives me 2x cubed. Then I have negative 2x squared and a positive 3x squared, which just gives me x squared. Then I have a negative 4x, and that's all by its lonesome. And then 5 and 2 makes 7. All right, when we talk about domain, remember, it starts off as all real numbers. When you start having an x under an even root or an x in your denominator, then you have to worry about those stipulations. There's no x's under an even root. There's no x's in a denominator, so therefore it is all real numbers. All right, and last but not least, we're plugging in negative 2. So we have f minus g of negative 2 is equal to 2 times, and then we're plugging in negative 2 everywhere we have an x. And remember, it's really important to put those parentheses around there when you plug in. It's not needed on all of them, but it is needed on some. And that ends up giving you 3. All right, so on 2A, I'm going to go ahead and I'm not going to show the work for distributing the negative. I'm just going to do it. So F goes in front. And just so you know, sometimes they'll even say like F minus F or F divided by F or F times F. Then you would just do it twice, right? All right, 4x squared minus 8x plus 4. And then we are subtracting this whole thing, right? So we're going to change all the signs. So minus 3x to the third plus 5x squared minus 6x plus 9. And then we're going to put that in order and combine like terms. So we have 2x cubed and negative 3x cubed, just negative x cubed. 4x squared and 5x squared, which makes 9x squared. Negative 8x and negative 6x, negative 14x. And 9 and 4, which is positive 13. All right, the domain on that, we don't have any x's under an even root, and we don't have any x's in a denominator, so that would be all real numbers. And then when we plug in negative 1, we have f minus g of negative 1. So negative 1 cubed plus 9 times negative 1 squared minus 14 times negative 1 plus 13. And that gives you 37. All right, now let's do some multiplying. So we're going to take f times g. So first I have f, and it's just one term, so I'm not going to put it in parentheses, times g, which is a root, so I'm just going to stick that right next to it. And there's nothing I can do to really simplify that, so I'm going to leave it as is. For the domain, I notice that I do have an x under an even root, so therefore x has to be greater than or equal to 0, since that's all that's underneath there, right? And then I'm going to plug 9 in for my x's. So I have f times g of 9 is equal to 9 squared times the square root of 9, which is 243. All right, so we have f times g of x. That gives me x cubed times the square root of x, right? Nothing I can do there. My domain, I have an x under an even root, so that would be x has to be greater than or equal to 0, since there's no number under there. And when I plug in the 4, I have 4 cubed times the square root of 4, and that gives me 128. All right, now to the dividing. So f is going to go on top, and g will go on the bottom. So the dividing ones are usually the most work. So if you can simplify, just like with anything, you should simplify. So for instance, I see that I have an x to the first on top and an x to the 3/4 on bottom, so I can simplify that. I have 6 divided by 1 is 6, and then 1 minus 3/4 is 1/4. So since I had the same base there, I could subtract their exponents. And I believe your textbook leaves it this way. But I feel like when you leave it this way, you don't realize that you have a root here, right? This is a 4th root. So I like for you to write it. That way you don't forget that you have a 4th root of x to the first, right? That way when you do your domain, you're like, oh, I have a 4th root here, right? I look underneath, I have an x. So my x has to be greater than or equal to 0. But you also had an x in your denominator. Even though it's not in your end simplified answer, it was still there in the beginning. So what number, if I took it to 3/4 power, would give me a 0 in my denominator? 0. 0 to the 3/4 power would be 0. So x can't be 0, so I'm going to take off the equal to bar so that I can combine those two domains into one. All right, then I'm going to do the plugging in. So f divided by g of 16 is equal to 6 times the 4th root of 16, which is 12. All right, so on this one, we've got f divided by g of x. We have 4x on top and x to the 2/3 on the bottom. And we can do the same thing, right, where we take 1 minus the 2/3. So we have 4x to the 1/3, which is a cube root. So we have 4 times the cubed root of x. All right? Then we talk domain. This is the same thing. I have an x under a root, but I only care about that if this is an even root. But this is an odd root. We can take the odd root of a negative. That's not a problem. Odd root of like a -8 would be a -2. So if it's an odd root, you don't have to worry about your domain at all right here. You only have to worry about this one. So the only thing that x can't be would be 0, because 0 to the 2/3 would be 0 in my denominator. So x cannot be 0. And then we'll plug in the 27. So we get f divided by g of 27 is equal to 4 times the cubed root of 27, which is 12. So now we're going to throw in just a couple extra. We're taking g times h. And notice that g and h both have more than one term. So you need to make sure that you put those in parentheses. So g times h. And anytime we have a binomial times a binomial, we need to multiply those, right? So 3x times x squared is 3x to the 3rd. And 3x times negative 1 is negative 3x. Negative 2 times x squared is negative 2x squared. And negative 2 times negative 1 is positive 2. I don't have any like terms here, but they're not in order, so I just need to reorder them. So the 3x to the 3rd will stay in front, but then next I should have the minus 2x squared, and then the minus 3x plus 2. All right, so h divided by g. So h will be on the top, and g will be on the bottom. So we have 2n minus 5 on top, and on the bottom, n cubed plus 4n squared. So this is a little different than what we did on the other ones that we were dividing. So when you have like polynomials on top and bottom, okay, I have 2 terms on top, 2 terms on bottom, I'm going to factor those if I can. So if I look at the 2n minus 5, okay, it's not the difference of 2 squares. There's nothing in common, so I can't do anything with the 2n minus 5. However, on the bottom, I notice that they both have an n squared in common, right? So I'm going to factor that out to the front. So if I take n cubed and I divide it by the n squared, that leaves me with n. And if I take 4n squared and I divide that by n squared, that gives me 4. And then I would look to see if I could cancel any factors out. For instance, this is one whole factor on the top. Do I have a 2n minus 5 that matches that on the bottom? No. So there's nothing I can cancel, so I'm just going to leave this way. But if I was thinking about the domain, okay, this will be my answer because that's all it's asking for. But if I was thinking about the domain, if it asked for that, the only issue I have is that I have some n's in my denominator, right? I have one factor here, and I have another factor here. I would need to set both of those equal to 0 so that I could see what x could not be. So if I set n squared equal to 0, n cannot be 0, right? That would be a part of my domain. And I would do the same thing with the n plus 4. N plus 4 equal to 0, so n cannot be negative 4. Both of those numbers will give me a 0 in my denominator, all right? But that would be the only issues. But again, it didn't ask for that. That's just extra info.